So, what's up everyone? Welcome to Top 10 Traffic Solutions, the future of transportation. If you've ever been stuck in bumper-to-bumper traffic just inching along, wishing you could just teleport, this one's for you. For a long time, the solution to more cars has just been more roads. But we're reaching a tipping point. Our cities are getting bigger, denser, and the daily gridlock is becoming a massive problem, not just for our time, but for the environment and our sanity. The real innovation, the stuff that gets me excited, is happening when we rethink the entire concept of getting from point A to point B. We're talking about going up, going under, and getting a whole lot smarter with the space we have. Alright, first up, let's talk about something that looks like it defies physics. Gyroscopic transport. Picture this, sleek, futuristic pods or cars, but instead of being on a wide road, they're balancing perfectly on a single, super narrow rail. This rail is elevated, running high above the existing streets, weaving between buildings. The key here, as the name suggests, is the gyroscope. Inside each vehicle, a massive, spinning flywheel creates immense gyroscopic force. This is the same principle that keeps a spinning top from falling over but scaled up to stabilize a multi-ton vehicle. It's an incredibly stable system, able to withstand crosswinds, shifts in weight as passengers move around, and even sharp turns. The biggest win here is space efficiency. You're not building massive new elevated highways that cast giant shadows and require huge support columns. You're installing a single, slender track. The road space below remains completely untouched. Okay, next on the list is a concept that went viral a few years back, and for good reason. It's the Transit Elevated Bus, or TE. This thing is less of a bus and more of a moving tunnel. It's a massive, wide vehicle that straddles two lanes of traffic. Its passenger compartment is elevated, sitting high above the road, while the rest of the traffic, the regular cars and trucks, can literally drive right underneath it between its wheels. Instead of taking up a lane of traffic like a traditional bus, the TB uses the space above the traffic. It moves with the flow of traffic, but is completely unaffected by gridlock below. A single TEB could carry hundreds of passengers, potentially over 1,000, making it far more efficient than a standard bus. You wouldn't need to dig massive tunnels or build miles of elevated tracks like you would for a new subway or SkyTrain. You'd be retrofitting existing roadways. Alright, let's move from on the road and over the road to something that hangs from above. This is SkyWay, also known as string transport. Instead of a heavy vehicle on a big track, imagine small, lightweight, automated pods suspended from a super strong, pre-stressed rail structure. The core technology here is the string rail. It's not just a simple cable. It's a sophisticated structure designed for minimal material usage, while providing maximum strength and rigidity. This allows for long spans between supports, meaning fewer pillars cluttering up the cityscape. The pods themselves are autonomous, electric, and can be summoned on demand, kind of like a personal taxi service, but in the air. This system is designed for flexibility. You could have different types of pods for different purposes. Small personal pods for 1 or 2 people, larger family-sized pods, and even cargo pods for moving goods. The network could snake through a city, connecting key locations like airports, business districts, and residential areas. It's a vision of a truly three-dimensional, on-demand transportation grid that is both fast and sustainable. So far, we've gone over the roads and above the roads. Now we're going under, not just underground but underwater. Let's talk about Hydropace. This is one of the more out-there concepts on the list, but it addresses a very specific and very real problem connecting coastal cities or crossing large bodies of water without relying on slow ferries or building incredibly expensive bridges. The concept is basically to build a network of submerged, vacuum-sealed tubes that lie on the seabed. Inside these tubes, pressurized pods, almost like underwater torpedoes for people, would travel at incredibly high speeds. Think of it as a Hyperloop system, which we'll get to later, but adapted for an aquatic environment. You're taking the shortest possible route between 2 points on a coast, a straight line, underwater. The engineering here is obviously a massive challenge. You need tubes that can withstand immense water pressure, systems to maintain a near vacuum state, and propulsion technology that can operate safely and efficiently in that environment. It would be completely silent and invisible from the surface, having zero impact on shipping lanes, marine views, or weather conditions. Storms, fog, high winds, none of that would matter when you're 100 feet below the waves. Let's bring things back to dry land, but stay underground. We're going to talk about a concept that takes a familiar idea, the subway, and pushes it to its logical, high-tech extreme. This is tube transport, which essentially refers to the next generation of vacuum tube trains. The fundamental problem with any high-speed vehicle, whether it's a car or a train, is air resistance. The faster you go, the more energy you have to spend just pushing air out of the way. Vacuum tube trains solve this problem in the most direct way possible. They get rid of the air. By pumping most of the air out of a sealed tube, you create a low-pressure, near-vacuum environment. With air resistance almost completely eliminated, a train or pod inside the tube can achieve incredible speeds with very little energy. We're talking about speeds that could approach supersonic, potentially over 600 or 700 miles per hour. This isn't just an incremental improvement over today's high-speed rail, it's a quantum leap. It would make a trip that currently takes hours by train feel like a short subway ride. So, we've talked about the general concept of tube transport. Now let's get specific with the one you've probably heard the most about, Hyperloop. This is the brand name, the vision that really brought the idea of vacuum tube travel back into the mainstream conversation. While the idea isn't new, the modern Hyperloop concept was popularized and open-sourced by Elon Musk back in 2013, sparking a new wave of innovation and competition. Hyperloop combines two key technologies we've touched on: a low-pressure tube and magnetic levitation, or maglev. The pods don't have wheels, they float. Powerful magnets lift the pod off the track and other magnets propel it forward at incredible speeds. By doing this inside a tube with almost all the air removed, you get the best of both worlds. No friction from the ground, and virtually no friction from the air. The promised speeds are staggering. We're talking over 700 miles per hour, or about 1,200 kilometers per hour. That's fast enough to travel from Los Angeles to San Francisco in about 35 minutes. It's a technology that completely redefines the relationship between distance and time. The vision for Hyperloop is a network of tubes, either on elevated pylons or underground, connecting major city centers. You'd arrive at a central station, board a pod, and accelerate smoothly to cruising speed. Let's shift gears from mass transit to something much more personal. This is the automatic mobile capsule. Forget driving, and honestly forget even owning a car. The vision here is a city where transportation is a service delivered by a fleet of small, autonomous, self-contained pods. Think of it as the ultimate evolution of ride-sharing, where the vehicle is designed for one purpose: to get you, and only you, where you need to go. The core idea is a fully autonomous system. You'd summon a capsule with your phone, a small, sleek, probably electric pod would arrive at your location. You get in, tell it your destination, and it handles the rest. There's no driver, no steering wheel, and no pedals. The interior is a personal space. You could work, watch a movie, or just relax. The real magic happens at the network level. These capsules wouldn't just be driving themselves, they'd be in constant communication with each other and with a central traffic management system. They would coordinate their movements to optimize traffic flow for the entire city. This means, well, no traffic jams, because the system would route pods to avoid congestion before it even starts. They would platoon together on major arteries, drafting off each other to save energy, and then split off for individual destinations. We've been on the ground, under the ground, and over the ground. Now it's time to finally take to the sky in a big way. This is the Bell Nexus, and it represents a category of vehicles that's getting a lot of attention right now: electric VTOL aircraft. VTOL stands for Vertical Takeoff and Landing. In simple terms, it's a flying taxi. The Bell Nexus is designed specifically for urban air mobility. It looks like a giant futuristic drone with a passenger cabin in the middle. It has multiple ducted fans or rotors that can pivot. For takeoff and landing, they point upwards, lifting the aircraft straight up like a helicopter. Once it's in the air, the fans tilt forward, and it flies like a conventional airplane. This design is crucial for city environments. You don't need a runway. A VTOL aircraft can take off and land from a very small footprint, like the roof of a building, a parking garage, or a dedicated vertiport. This means you can create a network of landing pads across a city, allowing for direct, point-to-point air travel that hops over all the congestion on the streets below. A cross-town trip that could take an hour in a car might take just 10 minutes in a Nexus, and a key feature is that it's designed to be quiet and clean. Unlike a loud, gas-guzzling helicopter, the Nexus is powered by a hybrid electric or fully electric propulsion system. The ducted fans also help to reduce the noise signature, which is a major concern for flying vehicles in populated areas. Okay. What if you didn't have to choose between driving on the road and flying through the air? What if your vehicle could do both? This is the idea behind the pop-up Airbus, a truly modular and transformative concept. It's not just a car, And it's not just a drone. It's a system that combines both into one seamless experience. It's a real-life transformer. Here's how it works. The core of the system is a passenger capsule, a small two-seater carbon fiber pod. This pod is the part you actually sit in. This capsule can attach to two different, independent, electric-powered modules. The first is a ground module, which is basically an autonomous car chassis with wheels. You click the capsule onto it, and you have a self-driving electric car for navigating city streets. But let's say you hit heavy traffic, or you need to cross a river, or you just want to get somewhere much faster. You would navigate to a designated area where a second module is waiting. The air module. This is a massive, multi-rotor drone. The ground module detaches and the giant drone swoops down, latches onto your passenger capsule, and lifts you straight into the air, flying you autonomously to your destination. It's a completely integrated multimodal system. The passenger never has to leave their personal capsule. The vehicle itself transforms around them based on the needs of the journey. Finally, we come to the traffic solution that's probably the closest to being a part of our daily lives: the self-driving car. This isn't about reinventing the vehicle itself, but about reinventing the driver. We're talking about level 4 and level 5 autonomy, where the car does all the driving all the time, under all conditions. It's a solution that works with the roads we already have. The technology is built on a sophisticated suite of sensors, cameras, radar, and LiDAR, which is like radar but with lasers. These sensors create a constantly updating 360-degree high-definition map of the car's surroundings. A powerful onboard AI processes all this data in real time, identifying other cars, pedestrians, cyclists, road signs, and potential hazards. But the real traffic solution comes when these cars start talking to each other. This is called V2V, or vehicle-to-vehicle communication. When every car on the road is autonomous and connected, they can coordinate their movements. A car can signal its intention to change lanes, and all the other cars will automatically adjust to make space. They can form high-speed, tightly packed platoons on the highway to improve aerodynamic efficiency and increase road capacity. This network effect is what will truly solve traffic. So, there you have it. 10 pretty incredible concepts that could completely redefine what it means to get around. From flying taxis like the Bell Nexus and modular transformers like the pop-up Airbus, to straddling buses and gyroscopic monorails, and all the way to underwater tubes and the near-supersonic Hyperloop, the future of transportation is shaping up to be a lot more three-dimensional and a lot smarter than the world we live in today. The common thread here is moving beyond the limitations of a human driver in a single car on a flat piece of asphalt. The tech is ambitious, and the challenges are huge, but the problems of congestion, pollution, and wasted time are very real. Which of these innovations would you actually want to try first? Let me know down in the comments below. If you're into this kind of stuff and want to see more deep dives into futuristic tech, definitely hit that subscribe button and turn on notifications. Your ride into tomorrow starts now. Thanks for watching, and I'll catch you in the next one.